welcome you in the lecture series of Basics of Communication Engineering. It is tutorial 5th based on lectures 13th and 14th. Now the question first is determine the percentage modulation for FM wave with a frequency deviation of 10 kHz if the maximum deviation allowed is 25 kHz. So the percentage modulation, it is equal to actual frequency deviation and divided by maximum allowed deviation into 100%. So here the actual frequency deviation, it is 10 kilohertz, and the maximum deviation allowed, it is 25 kilohertz. So it will be 10 kilohertz divided by 25 kilohertz into 100%. So from here you can see it will be 40%. So modulation index in percentage form, it is 40%. Now next question. In an FM system, if the maximum value of deviation is 75 kilohertz and the maximum modulating frequency is 10 kilohertz, calculate the deviation ratio and bandwidth of the system using Carson's rule. So here you have given the maximum deviation, it is 75 kilohertz, and modulating frequency FM, it is 10 kilohertz. You know the deviation ratio, it is equal to maximum deviation and divided by maximum modulating frequency, and it will be equal to del F by FM, and it is 75 kilohertz divided by 10 kilohertz. So the deviation ratio is 7.5. Now the bandwidth of the system using Carson's rule. With Carson's rule, the bandwidth of the system, it is 2 into the deviation plus modulating frequency. It is 275 plus 10 is equal to 170 kilohertz. This is the bandwidth of the system. Now question third is a sinusoidal modulating waveform of amplitude 5 volt and a frequency 2 kilohertz is applied to FM generator which has a frequency sensitivity of 40 hertz per volt. Calculate the frequency deviation, modulation index, and also the bandwidth. So here we have given the amplitude of the modulating signal AM, it is 5 volt, and the frequency of the modulating signal FM, it is 2 kilohertz, and the frequency sensitivity KF, it is given 40 hertz per volts. And the frequency deviation del F, it is KF into AM, and it will be equal to 40 into 5, it is 200 hertz. So the frequency deviation is 400 hertz, and the modulation index, it is MF equal to del F by FM, and it will be equal to 200 hertz divided by 2 kilohertz. So from here you can have the modulation index, it is 0.1, less than 1. So it is narrowband FM. And here the bandwidth of the narrowband system, it will be equal to the bandwidth of the AM system. And the bandwidth of AM system or narrowband FM system, it will be 2 into FM. So it is 2 into 2 kilohertz, and it will be 4 kilohertz. So bandwidth of this narrowband system is 4 kilohertz. So if here I am going to use the Carson's rule to find the bandwidth, and it will be 2 into del F plus FM, and 2 400 plus 2 kilohertz, so it will be 4.8 kilohertz. So you can see the comparison between bandwidths. So using Carson's rule, the bandwidth is 4.8 kilohertz, and the bandwidth actually for narrowband system is 4 kilohertz. So as I told you in the previous lecture, the Carson's rules will give you the approximated value when the modulation index is higher. Here the modulation index is 0.1, so we will not use the Carson's rule, and we will use as the concept the bandwidth of the narrowband FM is equal to the bandwidth of the AM signal. It is 2 FM and it is 4 kilohertz. Now question 4. An AM wave is given XCFT. It is 20 cos 8 pi tan is to the power 60 plus 9 sin 2 pi tan is to the power 3t. Calculate the frequency deviation, bandwidth and the power of FM wave. You know, here we have given the FM wave XCFT. It is 20 cos 8 pi tan is to the power 60 plus 9 sin 2 pi tan is to the power 3t. And we know the standard FM wave equation, it is XCFT, it is AC cos 2 pi FCT plus MF sin 2 pi FMT. And after comparing these two equations, we have AC is equal to 20 volts and FC is equal to 4 into 10 is to the power 6 hertz, or you can say it is 4 megahertz. And FM, the frequency of modulating signal, it is 10 is to the power 3 hertz, or you can say it is 1 kilohertz. And the modulation index, it is 9. MF is 9. Here you can see the value of modulation index is greater than 1. So we can say that this is wideband FM. And you know, the modulation index, it is equal to the deviation divided by modulating frequency. So from here the frequency deviation we can found it is MF into FM, modulation index into modulating frequency. So it will be 9 into 10 is to the power 3, or you can say 9 kilohertz. So the frequency deviation is 9 kilohertz. And now we can find out the bandwidth. You know, the bandwidth for wideband system we can use for this the Carson's rule, and it is 2 del f plus fm, and it will be equal to 2 9 plus 1, it is 20 kilohertz. So bandwidth for this wideband FM system is 20 kilohertz. We know that the power of FM and the average transmitted power, it is AC square by 2R. And if I consider that R is 1 ohm, then the transmitted power, it will be AC square 20 square by 2, it will be 200 watts. So the transmitted power by this wideband FM, it is 200 watts. Now question 5th. A 5 kilohertz audio tone is used to modulate a 50 megahertz carrier, causing a frequency deviation of 20 kilohertz. Determine the modulation index and the bandwidth of FM signal. Here we have given FM, it is 5 kilohertz. The frequency of the carrier is 50 megahertz, and the deviation given is 20 kilohertz. You know, the modulation index MF, it will be equal to del F by FM, and it will be equal to 20 kilohertz divided by 5 kilohertz. So it will be equal to 4. So the modulation index is 4, and you can see here the modulation index is greater than 1. So we can say this is wideband FM. And now the bandwidth for this wideband FM, you know, we can calculate the bandwidth for this wideband FM using Carson's rule, and it is 2 into del F plus FM, and it will be equal to 2 into 20 plus 5, and it is 50 kilohertz. Also, you can find out the bandwidth of the system using Schwarz universal curve that is given in your book Simon Hacken, and using that curve we can found that the bandwidth for this system it will be 3.8 into del f, and we can write it as 3.8 into 20 or 76 kilohertz. So this is using Schwarz universal curve, and this is using Carson's rule. So from practical point of view, the Carson's rule somewhat underestimate the bandwidth requirement of FM system, whereas the universal curve gives somewhat conservative result. So the choice of a transmission bandwidth that lies between bounds provided by these two rules of thumb is acceptable for the most of practical purpose. Now next question is, an FM signal with single tone modulation has a frequency deviation of 15 kHz and bandwidth of 50 kHz. Find the frequency of a modulating signal. So from Carson's rule, you know the bandwidth it is equal to 2 del f plus fm, and it will be equal to 50 into 10 is to the power 3 or 50 kilohertz. Bandwidth is given 50 kilohertz, so from here we can have 2 del f plus fm, it is 50 into 10 is to the power 3, or you can say 2 into 15. The del f is given 15 kilohertz, so 2 into 15 into 10 is to the power 3 plus 2 fm, 2 fm, it is 50 into 10 is to the power 3. So from here we can have 2 fm, it will be equal to 50 minus 30 into 10 is to the power 3. So fm it will be 20 by 2 into 10 is to the power 3, or fm it will be equal to 10 kilohertz. So the frequency of modulating signal is 10 kilohertz. Now next question is, a signal xt 5 cos 20 pi into 10 is to the power 3t frequency modulates a carrier signal AC cos 2 pi fct. Determine the modulation index and the bandwidth of modulating signal if kf is 12 kilohertz per volt. We know the modulating signal xt can be defined as am cos 2 pi fmt. Here if I compare with this equation, then I will have am 5, fm is 10 into 10 is to the power 3, or you can say 10 kilohertz. Here kf is given as 12 kilohertz per volts. You know the modulation index mf, it is given as kf into am by fm, and it will be 12 into 5 by 10, or you can say it is 6. So here we can see the modulation index is greater than 1 or 6. So this is wideband FM system. And you know the deviation del f can be represented as kf into am, and it will be 12 into 5, 60 kilohertz, and the frequency deviation is 60 kilohertz. And if you go for the bandwidth it will be, you know, from the Carson's rule, it is 2 del f plus fm, and it will be 260 plus 10, and it will be equal to 140 kilohertz. Now next question. An FM radio link has a frequency deviation of 30 kHz and modulating frequency 3 Hz. Calculate the bandwidth needed for the link. What will be the bandwidth if the deviation is reduced to 15 kHz from 13 kHz? So I'm going to reduce deviation 2 times. So here we have given in the first case when the deviation is 30 kilohertz and modulating frequency is 3 kilohertz. Now from this, the modulation index MF, it is del F by FM, and it will be equal to 3 by 30 by 3, it is 10. So the modulation index is 10. We can say this is wide band FM because modulation index is greater than 1. And the bandwidth for this system, it is 2 del F plus FM, and it will be equal to 230 plus 3, it is 66 hertz. Now in the second case I am going to reduce the deviation to 15 kilohertz. Now what will be the bandwidth in that case? So if I am going to reduce the deviation, then the modulation index will also be suffer. So in that case the modulation index, you can say it is del F by FM. Now del F is 15 kilohertz and FM is 3, so it is 5. You can see if I have reduced my deviation from 30 kilohertz to 15 kilohertz and still the modulation index is greater than 1, so still this is wideband FM, and the bandwidth for this wideband FM, it will be 2 del F plus FM, and it will be equal to 2 15 plus 3, and it is 36 kilohertz. So when del F is 30 kilohertz, then modulation index 6 and bandwidth was 66 kilohertz. And in the case when del F was 15 kilohertz, modulation index it was 5 and the bandwidth is 36 kilohertz. So there is a reduction in the bandwidth if I am going to reduce the deviation, frequency deviation, but there is slight change in the modulation index. Now the next question is, an angle modulated signal has the form Vt 100 cos 2 pi fct plus 4 sin 2000 pi t, where fc is 10 megahertz. Determine the average transmitted power. Determine the peak phase deviation. Determine the peak frequency deviation. And is this FM or PM? Explain. So the average transmitted power of FM is AC square by 2, and AC in FM wave, this is AC. Average power will be AC square 100 square by 2, and since here you can see 4 sine 2000 pi t represents the phase deviation at any instant t, and since the value of this for sine 2000 pi t is 1, peak value is 1, the peak phase deviation then it will be 4. So mathematically you can see the average power, it will be 100 square by 2, or you can say 500 watt, and the peak phase deviation, it will be, you can see, 4 radian. This is phase deviation 4 radian, and the peak frequency deviation, instantaneous frequency ft is 1 by 2 pi d by dt theta t. So from here we can have, it will be 1 by 2 pi d by dt, and theta t, this is 2 pi ft plus 4 sine 2000 pi t. So from here you can calculate, this is fc plus 4000 pi into cos 2000 pi. So the frequency deviation at the instant t is 4000 pi cos 2000 pi t, and the peak frequency deviation is 4000 hertz. Now it can be considered as PM, frequency modulated wave. It can be considered as PM wave with MP 4, phase deviation 4, and the modulating signal is sine 2000 pi t, and modulating signal sine 2000 pi t, or it can be considered FM wave with frequency with modulation index 4, and the modulating signal in this case will be cos 2000 pi t. Next question, FM is a constant bandwidth system. How? It is said that FM is a constant bandwidth system. Let us prove it by taking an example. Consider an FM system with deviation del F is 75 kilohertz and Fc is 100 megahertz and the maximum modulating frequency FM is 500 hertz. So with these parameters, the bandwidth for this system, it will be 2 del F plus Fm, and it will be 275 plus 0.5, it will be 151 kilohertz. And now, keeping everything else unchanged, and assume that I have changed Fm, and now the fm is I am going to change fm 10 times. So if I consider fm is now 5 kilohertz, so in this case, by using fm 5 kilohertz, the bandwidth is 2 del f plus fm, and it will be equal to 275 plus 5, and it will be 160 kilohertz. So comparing these two, we can find that corresponding to the 10 times increase in the modulating frequency, the percentage change in the bandwidth from 151 kilohertz to 160 kilohertz, there is only about 6% change in the bandwidth. That's why the FM is known as constant bandwidth. So this is the end of this tutorial, and in the next lecture we will discuss about the generation of FM waves. Till then, thanks for listening this tutorial. Thank you.